taking the set of natural numbers as the universal set, write down the complements of the following sets. That is, we have to take the set of natural numbers as my universal set. Natural numbers are basically 1, 2, 3, 4, 5, 6, 7, and so on until infinity. Now let's take a look at the following sets. X is an even natural number. If X is an even natural number, which means it starts from 1, 2, then it goes with 4, 6, 8, 10, 11, and so on. Now, the complement of an even natural number, in simple words, now if I take the complement of this would be 1, 3, 5, 7, 9, 11, and so on. Now, in simple terms, we can say that if there is an even natural number, and if we remove a complement of that from the set of natural numbers as a universal set, we get, let's say if this was a set A, then complement of set A would be the set of all odd natural numbers. Let's take a look at this next one. If X is an odd natural number, the same way that we did an even natural number, the complement of an odd natural number will be an even natural number. Third question, if X is a positive multiple of 3. Now, if we take this set, a positive multiple of 3, the numbers would be 3, 6, 9, 12, 300, 3000, 324. All those numbers which are a multiple of 3 would be considered as a given set. Now the complement of that given set will be those numbers which are not multiplyable by 3, which means that it is any number which is not a multiple of 3 will be the set of those natural numbers will be the complement of the third set. Let's look at the fourth question. If X is a prime number. Now prime numbers are those numbers which has only two factors. One is the number, it's one, let's say for example 29. Now 29 is a prime number because there are only two factors to this number. One is the number itself and the second is the number 1. Any such number in the real numbers, if it has only two factors, the two factors being itself and 1, then such a number is called a prime number. Now, if a given set is a set of prime numbers, then the complement of such a given set would be a set of composite numbers. Now, the composite numbers is exactly the opposite of a prime number, wherein a prime number has only two factors being itself and 1. A composite number will have multiple factors, maybe 2 or even more. Let's say for example 5 if I take 524, now it has so many multiples. First, we can divide it by 2. It is divisible by 2. Next, if we see, it's divisible by 4 because 4 ones are 4, 1, 2, 4 threes are 12, and remaining 4, 4 ones are 4. So it's divisible by 4. Now if we see, it is even divisible by 8. 8 ones are 8, 8 sevens are, no, 8 6 are 48. We are left with 4, 4. And thus we have so many multiples of the number 524. In such a case where it has so many multiples, that case we call that number as a composite number. If we look for a much more smaller number, let's say for instance 256. 256 is such a number which has so many multiples. It is divisible by 2. It is divisible by 128. It is divisible by 8. It is divisible by 4, and so on. There are so many numbers. Such a number is called a composite number. So that of all those composite numbers will be the complement of the given set of prime numbers. Let's take a look at the next one. If a natural number is divisible by 3 and 5. If a number is divisible by 3 and 5, which means that such a number is a multiple of 3 and 5, that is a multiple of the 3 of the product of these two numbers, that is 15. Which means if the given set is a natural number divisible by 3 and 5, it is a number which is divisible by 15, which means you are looking for the table of 15, that is 15, 30, 45, 120, 150, and so on. Any such number which is a multiple of 15 is a natural number divisible by 3 and 5. Now the complement of such a set is those numbers which are not divisible by 15, that is 31, 32, 43. All those numbers which are not divisible by 15 will be the complement of the given set. Let's take a look at the next question. If x is a perfect square. If any number is said to be a perfect square when it has a number which when divided by that number gives you the same second number. Let's say 16 is a perfect square. We call it a perfect square when we call the number a perfect square when we square it down to the second root, we get an answer which is the rational number, that is 4. For instance, if we take out the square root of 625, we get 25. But if we remove the square root of 627, we might get something that is 25 point something, which might be 25.12, 25.3 or something like that. Now, this particular kind of second type is called a non-perfect square, which means they can be squared, but you won't get a rational number. You will get an irrational number. But perfect square are such squares which when you square the square root, when we remove the square root of such numbers, we get a perfect number or a real number or a rational number. So the complement of such a set of perfect squares will be a set of all imperfect squares such as 627, 123, and so on. Let's take a look at this next question. If x is a perfect cube, if the given set is a perfect cube, then the complement of such a set, if a given set is a perfect cube, then the complement of such a set would be an imperfect cube. That is, for example, we know that The third root of 8 is none other than 2. Then we have 343 cube root being 7. Similar way, in the same way, these are all perfect cubes. Now, these are, let's assume this is the given set of perfect cubes. Then the complement of such a set from a set of natural numbers would be all those numbers which is not a perfect cube, or which does not belong to the set of perfect cubes. Now, here we have a linear equation. Here it's given x will take any value that will satisfy the linear equation x plus 5 is equals to 8. In other terms, we can say x is none other than 3. Now we are saying that a given set is a set in which x is 3. Then out of the set of natural numbers, then the complement of such a set is anything that is not 3, that is 1, 2, 4, 5, 6, 7 and so on. Thus the complement of set in question number 8, the complement of set x is any number that is not 3. Let's take a look at the next question. Here also we again have another linear equation where we have 2x plus 5 is equals to 9. If we solve it, we get 2x is equals to 9 minus 5, that is 9 minus 5, that is 4. If we further solve it, we get 2x is equals to 4, and we get x is equals to 2, which means that x can take only the value 2 in this given set, which means the complement of such a set in as per the given linear equation 2x plus 5 is equals to 9. The complement of this set would be any set where x is not equal to 2. In the next question, we have x greater than equals to 7, which means x can take, if we draw a axis line, we have 7, 8, 9, 10 and so on. Before that we have 6, 5 and 4. Now over here x can take any values from 7 and ahead, any values from 7 and more. Over here it can take any value from here till here, but it cannot take any values from the other side. It cannot take any value from this side. Thus we can say that the complement of such a set would be any values that is less than 7. Any value that is less than 7 can be called the complement, will be the complement of such a set. In the next question, we have x to be a part of a natural numbers, and x, and we again have another linear equation, but it's not an equation, it's an inequality. That is, we have to solve this one. 2x plus 1 greater than 10. Now if we solve this, we get 2x greater than 10 minus 1, 2x greater than 9, x greater than 9 by 2, or in other words 4.5. Now this is the given set in question number 11. The complement of such a given set would be, now this is saying x is greater than 9.9 by 2, which means any number that is less than or equals to 9 by 2 will be the complement of such a given set. Let's take a quick look at the solutions. Here u is this given a natural number, and if any number and even natural number, we have the complement as an odd natural number. Let a be an odd natural number. So if a is an odd natural number, then the complement of such a set will be all set of even natural numbers. If a is this, a is a positive multiple of 3, the complement of such set would be number of x which is not a multiple of 3. If a number is a prime number, then the complement of such set would be not a prime number or a composite number. If a is a set of natural numbers which is divisible by 3 and 5, which means the number is divisible by 15, which is a natural number divisible by 15, which means the complement is a number which is not divisible by 15. Next one, we had a perfect square, which means whichever the given set that may be, the complement of that set would be a not a perfect square. In the next one too, we have a perfect cube, and the complement of such a set would be not a perfect cube. In the next one, we have let a is equals to x plus 5 minus 8 is equals to 8, which we got the answer is 3. And in such a case, we have any number of x which is not equal to 3. In the next one too, we had x is equals to 2, which means the complement of such a set where x is equals to 2 is x is not equals to 2. Next we have x is greater than or equal to 7, which means any number which is less than 7, and any number x is 2x plus 1 is greater than 10, we have x is less than 9 by 2.